You are welcome to today's chemistry class. This is the second part of the topic, acid. And as I mentioned in the first part of the topic, acid, that we are going to complete everything about acid today on this part, or rather in this part. But before I move on, when I was treating basicity in part 1, the acid tetraoxophosphate 5, tetraoxophosphate 5. In the last part of the basicity, when I was writing the number of replaceable hydrogen ions that can be produced in 1 mole, I wrote this. And which is correct. But then I realized later that in the previous part, when I was explaining ionization, I mistakenly wrote this before basicity. I mistakenly wrote this. I wrote 2 negative instead of 3 negative. So please, this was an error. It was an error of omission. So it's supposed to be 3 negative. Take note of that. Okay? All right. Now, we want to move on. Today, we want to have a look at the physical properties of acid. What do you mean by physical properties of an acid? Things that can be physically seen about an acid, such as sour taste is one of the physical properties of an acid. When you taste an unripe fruit, you know that it will taste sour. That is to show that it contains what? Acid. But in that case of unripe fruit and vinegar, it is organic acid. As I mentioned in episode 1, part 1, that organic acid are contained in natural plants and animals. Okay. Acid turns blue litmus red. Yes. If you bring a blue litmus paper in contact with an acid, it will turn it to red. And when you have concentrated acid, it is corrosive. That means it can eat up an object like wood or skin. If it gets in contact with it, it can begin to eat up that spot. So that means it's not something to play with while in the laboratory. So the next thing now is chemical properties of acid. All right. One of the chemical properties of an acid is reaction with metals. Anytime an acid reacts with a metal, hydrogen is liberated as a gas. But there is a condition to that, and that condition is what is written in the bracket. It is not every metal that can liberate hydrogen from a metal for one reason or the other. One of the reasons is that if the metal is below hydrogen in the series of reactive metals, that is, if the metal reacting with the acid is positioned below hydrogen in the series, hydrogen will not be liberated. Why? Because that metal will not have the capacity to displace hydrogen from the acid. Why? Because it is lower than hydrogen itself in the series. But when the metal is higher in position than hydrogen in that series, then that metal has the capacity, has more and enough energy to displace hydrogen from the acid. and take over its position. Let me give you an instance of an equation. Now, for example, now if you say zinc, or let me say, okay, sodium reacting with hydrochloric acid, that will now give us sodium chloride, then hydrogen will be liberated. So all I need to do now is to balance the equation. And it's balanced now. So you can see that this sodium has taken over this hydrogen here, and this hydrogen is now on its own, it's being liberated. But this is possible because sodium is higher than hydrogen in the series of betas, which I'm going to give you before the end of this video. Another reason is that if the acid in question is a strong oxidizing agent, for example, triazonitrate 5 acid, HNO3, is a strong oxidizing agent. So whenever it reacts with a metal that is higher than hydrogen in the series, it will not liberate hydrogen as a gas. Instead, water will be produced. It won't be, and an oxide of nitrogen also will be produced. So it won't liberate hydrogen. Only oxide of nitrogen and water will be produced. Another chemical property of an acid is the reaction of an acid with bases. When an acid reacts with a base, that process, that kind of reaction is called the neutralization reaction. And salt and water only is produced. Now, for example, this is sodium hydroxide, which is a base, reacting with tetraoxosulfate 6 acid. Then a salt, which is sodium tetraoxosulfate 6, and water will be produced. The next thing is to balance. Yes. So this is salt and this is water, as we all know. Another property, which is a chemical property, is reaction with triazocarbonate. Whenever an acid reacts with any triazocarbonate for salt, carbon 4 oxide, which is also called carbon dioxide in old name, is always liberated. For example, let me take potassium triazocarbonate 4, then reacting with, let's say, hydrochloric acid. That will give us potassium chloride, water, and carbon 4 oxide will be liberated. Let me balance the equation. Yeah. Okay. So this is an equation, e.g., this is an example of an equation in which an acid reacts with triazocarbonate salt, 4 salt, to liberate carbon 4 oxide. We can see that salt and water are produced here. Why? Because this can also serve as a base. Why this is an acid? But this has dual purposes. It can serve as a base and as well is a salt. Potassium triazocarbonate 4, sodium triazocarbonate 4. Both of them can function as a base and as well as a salt. These are the 3 characteristic properties of an acid. So finally, we want to see how we can prepare acid in the laboratory. One of the methods of preparing acid is to dissolve, acid anhydride in water. What do we call acid anhydride? Acid anhydride is any non-metallic oxide that will produce an acid when dissolved in water. But it is not all metallic oxide it is not all non-metallic oxide that are acid anhydride. Take note. So I'm going to give you examples of acid anhydride. Examples of acid anhydride are carbon 4 oxide, nitrogen 4 oxide, sulfur 4 oxide, sulfur 6 oxide, etc. Whenever any of these is dissolved in water, it produces an acid. For example, these are equations to back up acid anhydride dissolved in water. In the case of nitrogen 4 oxide, it has to be dissolved in water in the presence of excess air. Yes, that is why we have excess oxygen here in addition, because you know that nitrogen covers the highest percentage by volume of air. So the next thing now, we want to talk about another way we can prepare acid. Another way of preparing acid is through the combination of constituent elements. When we say constituent elements, we mean the elements that combine together to form that acid. We also call this one direct combination. For example, 1 mole of hydrogen gas will react with 1 mole of chlorine gas to produce hydrochloric acid. Yes, though it can produce hydrogen gas, like I mentioned in the part 1 of this topic, acid. Hydrogen chloride gas, it can produce hydrogen chloride gas, but the hydrogen chloride gas can be further dissolved in water to produce hydrochloric acid. So this L shows liquid. Liquid means it's an acid. If I put G there, it means a gas. Take note of that. Alright, finally, the third method is what we want to have a look at, and that is using a strong acid to displace a weak acid. Using a strong acid. When we want to prepare a weak acid, we use a strong acid to react with a salt that contains the what? The anion part of the weak acid. For example, if I take sodium chloride to react with H2SO4, which is that's tetrasulfuric acid. This acid is one of the strong acid. You are going to have sodium sulfate and hydrochloric acid. Let me balance it. So this is a strong acid, and this is weak compared to this. So that means we use strong acid to bring out this weak acid, HCl, from the salt. So take note of that. Okay? These are few out of many uses of acid. In fertilizers making, in detergent making, production of drugs. They are used as drying agents, that is, they can be used to dry some other substances. Used as catalyst, a catalyst will alter the rate of chemical reaction, and as an oxidizing agent. So, these are the few out of many. This ends the end of the topic, acid. In my next video, I'll be talking about bases. What are bases? Please take note of that.